Okay, so in this lesson what I'm going to talk about is how to name carboxylate ions and carboxylate salts. So carboxylic acids are, as their name implies, they're acids. So as we saw already, this would be called butanoic acid. What happens, though, is this proton, the proton on the carboxylate group, is always, or carboxyl group, is always acidic. Different acids have greater and lesser acidities, but they can always act as acids. And when we say that this is acidic, what we mean is that it can donate that proton off to a base. So that proton goes away and leaves an ion. So the H plus leaves a negative charge on the resulting ion. Now when we name it, we're going to name it, now notice that its structure is exactly the same as butanoic acid, with the exception that it doesn't have the H on the end and it has a charge. So while this is actually an acid, this is an ion. So we're going to name it almost exactly the same. Butanoate instead of ic ion. So this is just a lonely ion, the butanoate ion. We can carry this all the way out to as complicated of a carboxylic acid as you can name. You can name its corresponding ion. So if I have something like this, go. So this is something we should be able to name. Let's stick one more there. So the longest chain should be 1, 2, 3, and I drew the acid. Actually, yeah, let's go ahead and do that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 down if you went down. So this is the longest chain for sure. So this means that this acid name is hexanoic acid, and we're going to have some substituents on the front. So alphabetizing, we're going to have a methyl group, looks like a propyl group, and a chloro group. So 3-chloro, 4-methyl, 2-propyl, and that ends up being a little too long, but I'll rewrite it again when I do the ion. Now, to name the corresponding ion, it's exactly the same. It becomes 3-chloro, 4-methyl, 2-propyl, and the ending becomes hexanoate ion, as opposed to hexanoic acid. So this is 3-chloro, 4-methyl, 2-propyl hexanoate ion. So it's named in exactly the same way. So having gotten that down, let's talk about salts. Okay, so let's talk about salts. When you react a carboxylic acid with a base of some kind, remember, bases accept protons. So what happens is it strips all the protons off, and what happens is you'll have the sodium left over. So the H and the OH go off and make water, and then you have lonely sodium plus hanging around. So what we have is and this would be a propanoic acid, as you would expect, but not propanoic. I keep saying propanoic acid. I'm sorry. This would be a propanoate ion. So this would be a propanoate ion. And what happens is the sodium, being positively charged, wants to hang around the negative charge. So just like when we talked about ionic compounds before, sodium, this is called, actually I should start from another point. I should say This is the chloride ion. This is the sodium ion. Together, they are sodium chloride. So when we name the whole compound, we drop the words ion and we just put them together, cation, then anion. And so carboxylate ions are always anions. They're always negatively charged. So what happens is, if the sodium is there, it's now a salt. It's a whole compound, right? We have this ion and this ion together, and they make sodium propanoate. So we drop the word ion. So this ion is called propanoate ion. The whole compound is called sodium propanoate. So this just scales up from anything that you've seen. So now that you know how to name carboxylic acids, you can name ions, and therefore you can name salts. So let's start with this. Let's do something like this. So this is carbon, actually. Let's do this. So this is carbon 1, 2, 3, 4. So this is 2,3-dimethyl butanoate. If I have a sodium, actually let's shift gears. Let's do a potassium ion hanging out here. Then what it becomes is this is now potassium 2,3-dimethyl butanoate. So if you can name carboxylic acids, you can name carboxylate ions, and you can name carboxylate salts.